Hi everyone, today the STEM shortcut presents Rationalizing the denominator. So first of all, let's look at some rules that determine whether a radical expression is in its simplest form. So these rules state that no radicand have a perfect square factor other than 1, no radicands contain fraction, and no radicals appear in the denominator of a fraction. Now, if you're confused on what a radical or a radicand or index right here, you can take a look at this parts of a radical diagram, and it can help you understand these rules a little better. So let's take an example of the first rule. We have the square root of 625, and well, obviously 625 has two square factors, which is 25 and 25. And using our product rule, we can split these factors and get our answer right here. So even if this wasn't a perfect square number like 625 is, we can still use our product rule to split them and make sure no radicals have nothing in the square root sign is a perfect square other than 1. Okay. Next, we have no radicands contain fractions, and we can simplify this using our quotient rule right here, which states that the square root of a divided by b is equal to the square root of a divided by the square root of b. And so right here we've used our quotient rule to simplify this radical expression. Lastly, we have no radicals appear in the denominator of a fraction. Now, even when we're using the quotient rule, we might still find ourselves with radicals in the fraction in the denominator of the fraction, and we can't have that. So I want you to try picturing this. You're trying to divide 3 by the square root of 2. It's impossible to get a perfectly correct answer, right? Because the square root of 2 is rational and its decimals are non-terminating. So we can't divide something by an irrational number because we would never get a correct answer, which is why we have to do something called rationalizing the denominator. So first thing I want to clear up is that anything divided by itself is 1. 2 divided by 2 is 1. And the square root, and also the square root of 2 divided by the square root of 2 is also 1. So if we need to move a radical from the denominator to the numerator of the fraction, we can multiply the top and bottom by 1, but which won't change the value of the fraction, but if we use it like this, it will move the radical in the denominator to the numerator. So let me just visualize this for you guys. We have x divided by the square root of y. So using this rule, we want to move the square root of y up to the top. So we use this rule right here to multiply the top and bottom by the square root of y, which is just 1. So it won't change the value of the thing. So the square root of y times the square root of y is y, and x times root y is x root y. So this is our fully rationalized and fully simplified answer that adheres to our rules. Now, if you're wondering how are these the same, right? Well, I want you to take a look at this. So this y is just the square root of y times the square root of y, and these two root y's cancel out when you expand the expression. So you would just get x over root y, which is the exact same thing as this right here. It's what we started with over here as well. So now that you've learned that, I want you to try some of these practice questions right here. We have 20 divided by the square root of 5, 4 root 3 over 3 root 6, and 4 divided by 1 minus root 2. Don't worry if you can't get the third one just yet. It requires a little bit more advanced knowledge, which I'll tell you guys after. So feel free to pause the video and give these expressions a try. Okay, so the first one is pretty simple and straightforward. We just use our rule and multiply the top and bottom by root 5. So we get 20 root 5 over 5. Now, we want to make sure these fractions are always in the most simplest form. If you had this question on your exam, and this was your question, you wouldn't get the full marks if you left your answer like this. You need to have it fully simplified. So obviously the common factor between 20 and 5 is, well, 5. So we have 4 times 5 times root 5 over 5, and the 5's cancel out, so we get 4 root 5 divided by 1, which is just 4 root 5. For the next question, we have this 4 root 3 over, 4 root 3 divided by 3 root 6. Now, one important thing to note is that you only need to deal with the radical in the bottom of the fraction. We don't care that there's a root 3 on top, because it's fine if it's on the top of the fraction. We only deal with what's on the bottom of the fraction, because remember, we can't divide by an irrational number. So we multiply the top and bottom by root 6, and we get our simplified version right here, and which is just 4 root 18 over 18. Now we can use our product rules right here to simplify root 18, which gives you root 9 times root 2, and the square root of 9 is 3. So you get 4 times 3 root 2, which is 12 root 2, divided by 18. And yet again, 12 and 18 have a common factor, which is 6. So you cancel them out, and you get 2 root 2 over 3, which is our final answer. Lastly, we have this question right here. It's all right if you didn't get it when you started it, but when you have a denominator of a fraction, and the denominator has 2 terms in it, one of which is a surd, you need to multiply by the conjugate of the expression. So what this means is that whatever sign that you have between your 2 terms or more, you take the opposite of that sign. So if we had 1 minus root 2, we would multiply by 1 plus root 2. Now this is because of the difference of squares rule, and this is the only way that you would get the third term out of the denominator of the fraction. So you can try other ways. You can multiply this by just root 2 or 1 minus root 2, but this is the only way that you would immediately get the surd out of the denominator of your fraction, thanks to the difference of squares rule right here. So like when so a squared minus b squared, 1 is a, root 2 is b. So b squared obviously is just going to be 2, and you have 1 minus 2. But if you had if you multiplied with any other rule, it wouldn't work the same. You wouldn't get a rational answer. So we multiply by we multiply by 1 over root 2, 1 plus root 2 on the top and bottom of the fraction. And using, again, our difference of square rules, we would get 4 plus 4 root 2 over negative 1. And we multiply the top and bottom by negative 1 to get rid of that negative in the denominator. And we get negative 4 minus 4 root 2 over 1. But this is, again, it's just itself. And so that's how you rationalize the denominator when you have 2 or more terms in the denominator of the fraction. You use the conjugate. Anyways, that's it for this video. I hope you now you know all 3 rules to simplify a radical expression to its fullest. I hope you enjoyed. If you have any questions, feel free to ask them in the comments, and I will reply as soon as possible. Have a good day, and bye bye.